Today we tackle derivatives of trig functions, and we're going to start out with one of the most basic trig functions, that being the sine. And here we have a graph of the sine. And let's say we didn't know what the derivative of sine is. So let's graph the derivative like we learned how to graph derivatives. We're going to find places where the slope is 0. Slope is 0 here, so I'm going to make sure the value of the derivative is 0. And I keep finding those places where the slope of the function is 0, so the value of the derivative is 0. And then I'd say, well, over here it looks like the slope is positive, then it becomes negative, then it becomes positive, then it becomes negative, then it becomes positive. And so I'm going to have positive values pass through my 0, and I'm going to have something that looks like this. If I look at that, this thing, when x is 0, we have a value of 1. At pi over 2, we have a value of 0. At pi, we have a value which is apparently negative 1. And so we're going to recognize the derivative of sine is cosine. And those of you who had AB last year, you remember that. And so if the derivative of sine is the cosine, would it make sense that the derivative of cosine is sine? Well, we check that out here. We've got cosine. And again, we could plot where the zeros are. Now, apparently here at pi, there is a slope of 0, so the value of the derivative is 0. And it appears as if maybe right here, right in the beginning, maybe there is a value of 0. Maybe that would be at 0. And out here at the end, it kind of looks like the slope might be 0. That would be out at 2 pi. And so therefore the value of the derivative is 0. But what we see here is in between this 0 and that 0, we have negative slopes. The value of the derivative is negative, then it becomes positive. And so we'd have something that looks like this. And no, that's not what sine looks like. This is what sine looks like. Sine starts at 0 and it's 0 at pi, but it goes up before it comes down. And so the derivative of cosine seems to be the opposite. The opposite of what we're seeing here. The derivative of cosine would be negative sine, or the opposite of the sine of x. So anytime you're looking for the slope of the cosine function at any x value, just put that x value into the opposite of sine and you'll have the slope. Okay, 101st derivative of sine. Really sounds to me like something Mr. Amundsen would ask. So I can get rid of that little bubble. There we go. 101st derivative, all right. See, we start out with sine. Oh boy. And the first derivative is cosine. And the second derivative, well, derivative of cosine is the opposite of sine. Third derivative is a derivative of sine. Well, coefficient come along for the ride. Fourth derivative, coefficient come along for the ride. And so we would just have sine. We'd be back to where we started, which would mean that the fifth derivative would be cosine. And this pattern of 4 is going to continue to repeat itself. So this is the fourth derivative, the eighth derivative, the 100th derivative, anything divisible by 4, which would mean the 101st would go back up to being cosine. So in any of these bizarre kinds of questions, make sure you are looking for some kind of a pattern that might help you out. Derivative of secant. Now, some people remember what that is, some don't. Derivative of secant. Now, how would I find the derivative of that? Let's see, I'm looking for the derivative. Remember what secant is. It's 1 over cosine. And so I could do a quotient rule here. I could do low d high minus high d low over low low. And I could say that I've got positive, opposite of the negative, I got positive sine, whoopsie. I did low, I should have done low, low, sorry about that. Cosine squared. And some people might stop right there and say, that's the derivative, and I can't argue with you, it certainly is. Other people could say this is the sine of x over one of those cosines times 1 over the other cosine. And you've got tangent times secant. So the derivative of secant, the most accepted way of writing derivative of secant, is secant x tan x. So that's where that comes from. And we could do that with any of these trig functions, tangent, cosecant. The ones you really got to know is you got to know the derivative of sine, cosine, tangent, and secant. When it comes to AP testing, they never ask the other ones, cosecant nor cotangent. You may have to find it as homework problem, but you won't have to find it in terms of any assessment that I'll give you. Find the derivative of the other trig functions in section 2.4. There's a table in section 2.4 if you have to look any of them up. For those of you who haven't had the trig functions or need to familiarize yourself, look through section 2.4 and be looking for a table in a red box that has the derivatives of trig functions. Now, this is a good one. Where's the tangent line to this function horizontal? Okay, now what piece of knowledge do we have to have in order to find where a tangent is horizontal? Well, hopefully what you're saying is that the derivative of f of x has got to equal 0. So you have to find the x values that give you a slope, a derivative of 0, and it certainly looks like this is going to be a quotient rule. Now, a trig identity, which you really are not held accountable for, but you had back in probably pre-calc. This is a trig function we're going to need to solve this problem. If you don't run into a situation where you need this, well, then you done goofed up someplace. So, go ahead, use your quotient rule on this guy. Try to figure out the x value where this is equal to 0. At this point, I'm going to pause. I'm going to do some work. We'll compare our work when we're all done. All right, so here's what I've done. I've done a low d high minus high d low over low low. And then I actually, multiplied this stuff out on top. Anytime a fraction has a value of 0, and make sure that you show that you are setting the derivative equal to 0. Anytime a fraction is equal to 0, it's because the numerator is. So I'm just going to focus my attention on the numerator. And when I distribute this secant squared, I get my secant squared, secant cubed. Here I've got a secant, I've got a tan squared. So that's where this step comes from. Now I notice everything has a common factor of secant, so I'm going to factor out the secant. And I got a secant squared plus a secant minus a tan squared. And secant squared minus tan squared is 1. So that's where this step came from. So now, when is secant equal to 0? When is 1 over the cosine of x equal to 0? Well, never, because the numerator is always 1. So then when is 1 minus secant? Oops. It should be 1 plus, sorry about that. 1 plus secant. When is 1 plus secant equal to 0? Well, I think that's going to happen that is going to happen whenever the secant is negative 1. So if I multiply both sides by cosine, when is the cosine of x equal to negative 1, or the negative cosine equals 1, cosine is negative 1. When is cosine negative 1? And I think that happens at x is equal to, and I'll just do my first time around the unit circle. James might have an infinite number of answers. I'm just going to say I want an answer between 0 and 2 pi. All right, so probably should have been more clear on what our domain was, 0 to 2 pi. But yeah, at x equals pi, we are going to have a slope of 0. Okay. Boy. You know, nice solution. Nice solution. This is our original problem. Would pi make the bottom 0? Is pi even in the domain? I don't think pi is in the domain of our problem. And if pi is not in the domain of our problem, yeah, we came up with a nice x value. But if we're being conscious of what our domain is, I guess we'd have to say that as our final answer. Interesting. Wow. That's awesome. Okay, let's move on. Okay, now we want to find the derivative. We want to find the slope of this function at a particular x value. Looks like we're going to have to tackle this using the product rule, where this will be our first function, and this will be our second function. So once we find the derivative, let's find the derivative using x's. And then, once we found the derivative, let's put a pi over 4 in for all of those x's. And when we come back after a brief pause, let's compare answers. All right. First times derivative of the second, plus second times derivative of the first. I'm not going to simplify that. I'm not going to make a lot of mistakes simplifying. I'm putting in my pi over 4 and taking my chances. And no calculator problem. I better know my unit circle. So I replace all my x's with pi over 4. And now, knowing my unit circle, hopefully, I put those values. Now, for secant is the reciprocal of cosine. So, cosine of pi over 4 is this. So secant is just going to be the reciprocal. 2 over the square root of 2, I got to square that. Sine, yeah, okay. So I put all those in there, and what I'm going to get in the end is, when I square this guy, I'm getting 2. So I got 2 square roots of 2. This is going to be minus. This is a multiplication sign. That's a negative sign. Multiply this out, and I think we get square root of 2. So the slope of this function, when x is pi over 4, square root of 2, or 1.4-ish, is going to be the slope. All right, and I think that brings us, that brings us to the end of the discussion of derivative of trig functions.